Good morning, everybody. Welcome to this, first regular session of the day.
Yeah.
Thanks for showing up in such numbers. We have plenty of good stuff for you this morning. This is a live demo session, so don't expect any slides. We're going to.
No, there's slides. Look.
Well, there's a kind of slide. This is the only one we have for you. We're going to run you through, a couple of steps at code level. We're going to demonstrate a few Reactive Spring coding patterns. This is Reactive Spring Revisited, because it's kind of a follow-up to a session you've been doing last year. And it's generally revisited in the sense of very up-to-date with Spring Framework 5.2, Spring Boot 2.2 level. So we'll spend considerable time on very recent features, such as reactive transactions, and in particular RSocket. So there's some RSocket coming your way.
Good stuff. Before we get too far into the way, though, I think we have forgotten something very important.
Oh, yeah.
Yeah. So I have a daughter, and she's a teenager, and she's very smart. But she's smarter than I am. So when I go to these conferences now, I like to take selfies with the audience, right? And I take these selfies, and I go home, and I show the selfies to my daughter, and I say, see, they listen to me. So that's what we're going to do. We're going to take a selfie together, all of us, okay? Is that okay? Okay. Okay, so...
Quick one.
Quick? Oh, sure, quick, yeah. Wait, I guess we go over there. When I say open source, you say open source, okay? Ready? Open source! Oh,
okay.
It's crazy.
That was it.
Good stuff. All right, my friend. Well.
So, what's the topic again? Reactive Spring.
Who are you?
And who's speaking? That's a quick note. Let's keep it brief. So, hi, I'm Juergen, Spring Framework Lead ever since the dawn of time, more or less. I've in particular had the privilege and the pleasure to guide Spring through its recent evolution as well. And the Spring Framework 5.2 release is something we've been very busily working on. So very recently released, Spring Framework 5.2 GA, September, Spring Boot 2.2 GA just a few days ago.
Yeah.
And I'm very involved also in the phase that started right now. As you may imagine, any GA release always has a lot of maintenance following up. All right, who are you, Josh?
My name is Josh Long. I'm a Spring developer advocate on the Spring team. Super happy to be here, and we have very little time. So take one photo. I just took my photo for the hour. This is the photo that you should take, this slide, because it has, first of all, our coordinates. If you have questions or comments or whatever, you can find us on the internet. And also the code. So if you want to follow along at home, you can. There's the code there. So if you have questions, comments, feedback, whatever, you can find us there. Okay? All right.
So back to the topic.
Reactive Spring, right? So we're going to talk about reactive programming, and I think this is becoming a more popular topic these days. But I think the real power here, the real phenomenon, is that it's now become something that's integrated in our everyday sort of use cases, right? This is where I think Spring has offered the big first step for most people.
It is. So in particular, from a current perspective, what we're doing in 5.1 and 5.2 recently, what we've been doing there, it's really showing that we have a quite unique approach in how we allow you to go into reactive programming within a Spring-based setup, a Spring-based application. You might be aware that there are pure forms of doing these things. Spring Web Flux, the reactive web client. We allow you to go all in for an entirely reactive event loop-based architecture, a web architecture, server-side as well as client-side. And as we're going to see, messaging architectures as well. But we also allow you to do it in a kind of toolbox fashion, piecemeal, for certain kinds of use cases. We allow you to use reactive programming within Spring MVC on a servlet architecture, trying to do the best we can with reactive pipelines that you hand back to us, translating them onto servlet async streams. So reactive programming is many things in many areas of Spring these days. Reactive database access, reactive transactions, even reactive application event listeners. There's many things you can do now in a reactive programming fashion. And if we say reactive, we usually mean based on the Reactor API, Flux and Mono, which is what we're going to show today primarily. But we also mean other reactive types that we're able to adapt. So you could also choose to use RxJava. You could, for certain use cases, completable future might be all it takes. So there's many facets, many variants. And why would you want to do this?
Good question. So for a long time, we've had this very simple question, which is, how do I handle more users? How do I scale to greater heights? And for the last 10 years, I don't think it's been a very difficult problem to answer, because there's always been at least one answer, right? The question is, how do I handle more users? Well, traditionally, if you couldn't scale any more on one computer, there's a very easy answer. I love this answer. It's an answer that, because we work at a cloud computing company, right? So we love this answer. This answer is very simple. If you want to scale out, you just create more app instances. We make money, you get more users, everything's good, right? Love that answer. But the question is, why can't we handle more users on a single computer? Why can't we handle more users on one node? And the problem here is that for the longest time, it's become obvious that our ability to scale a single node is saturated. There's a bottleneck there, and our ability to create more threads. And then once we do have that scale, once we do have more users, the next problem that people confront is they don't have an effective way to deal with or to program around the fact that they're talking to disparate distributed systems where things will happen, errors will happen, failure could happen, right? So we don't have a programming model that encourages reacting and responding accordingly to that situation. So today we're going to talk about how reactive programming gives us the ability to make more efficient use with our existing currently limited resources, and to program in such a way as to be able to respond gracefully to changes in network topologies and things like that, right? So in order to do that, of course, we're going to go to my second favorite place on the internet, our second favorite place on the internet, after production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It is better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. If you need inspiration in the early morning before a cup of tea or coffee, start.spring.io. If your children are restless and they cannot sleep, start.spring.io. And if you suffer from indigestion, a sour stomach, after a long night of alcohol abuse and PHP, start.spring.io. So we're going to build a new application today, my friends. We're going to take advantage of the latest and greatest. We're going to use Spring Boot 2.2. That brings in Spring Framework 5.2. We're going to build a new thing called a service, right here, a service. And the service, it's a Java application, and we are confronted with some basic questions. The first question, of course, is the choice of packaging. What type of packaging do you want to use in 2019? There are some obvious answers here. If by some crazy, terrible accident of physics, you find that you have been transported to the distant, distant past, far, 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 far beyond modern help, then choose .war. But if you're here with us in 2019, then choose .jar. This is a big part of our overarching and guiding personal philosophy of make jar, not war. And again, lots of things that you could do. But I encourage you to stick with the defaults. Then, my friends, we have the choice of the JVM version that you would like to use in 2019, almost 2020. There's 2 acceptable answers here, my friends. Of the 3 that are listed, only 2 are acceptable. I'm going to give you a clue about which one is not acceptable. That one. It's not acceptable. It's the wrong version of Java to use in 2019. It is the baseline required version for Spring Framework 5.0 and later, but it's still the wrong version. We are in 2019. We should use the current version of Java, or at the very least, the current supported, long-term supported version of Java. So you have 2 choices here, 13 or 11. These are the correct versions of Java. This is the incorrect version of Java. It's not just incorrect technically, because it's inferior, it's slower, it has more bugs, it's not as secure. It's not just incorrect technically, it's also incorrect morally. Do you want to go home and have that discussion with your children that you're still using Java 8 in production? Are you ready for that conversation? I don't think you are. No, friends, use Java 13. Don't just do it for me, do it for the children. So now we've got a new application using Java 13, and we have to bring in some dependencies that we need. We need the reactive web support, we need Lombok, and we need to bring in some sort of data access tier. We have some options here. What are the choices?
Quite a few, right? If we're building a reactive application, of course, it's kind of driven by the availability of reactive data store clients, reactive data store drivers. But there's still quite a few. There's MongoDB, there's Neo4j, there's Redis, and there's a new game in town, R2DBC, for relational database access, reactive relational database access, a currently Pivotal sponsored project that is coming with backend implementations for like everything from Postgres to there's a contributed MySQL driver, there's an effort for MS SQL Server. It's basically a sort of JDBC on reactive, a reactive rethinking of what JDBC means to abstract. And it is our kind of solution for the gap in the reactive story. Relational databases, of course, having such a central role in the enterprise. How do we integrate them into purely reactive applications, into a pure reactive stack? R2DBC is our immediate answer here. It's currently still in sort of pre-release, stable but pre-release stages, intending to go 1.0 GA soon,
right?
in 2020.
Right now we're at a 0.8 release, and this is, I think, pretty feature complete except for stored procedures, right?
Yep.
And we have waited until other community members contribute their implementations to sort of solidify the API. Right now there's 5 different implementations that I'm aware of. There's what we talked about, PostgreSQL, H2, Microsoft SQL Server, MySQL, and Google Cloud Spanner, right?
Yeah.
But there are more coming. I know of at least 5 other ones that I'm not sure I can talk about yet that are coming. So
we're also working with the corresponding vendors, because it's really the data store providers, the data store vendors who are in the best position to come up with a reactive driver. They know the wire protocol, they know the specifics of their data store. So going forward, we mean to cooperate with them. Ideally, they would also be willing to maintain the drivers that they contributed. We really mean this to be a production tool. We love production, after all.
So good. So let's hit generate. I've added RSocket. We're going to talk about that later. Let's hit generate. And we're going to open this up in my IDE. It doesn't matter what IDE. I don't care. How many of you using IntelliJ? I'm always curious. Who uses IntelliJ? Oh, that looks like the large majority. How many of you using Eclipse? Eclipse is good stuff. I love Eclipse too. Good stuff. No, it's fine. There's some of you. I see a bunch. Yeah.
I saw one.
What about NetBeans? Who uses NetBeans? Good stuff. Right on. Good stuff. What about Emacs? Are you here, sir? Where's the Emacs guy?
There he is. I think it's the same hand as for Eclipse, though.
Yeah. Every single city and country that we go to and we talk to people, every time we ask, who uses Emacs? It's the same guy. The same one. I say, who uses Emacs? He says, I do. And then he leaves to meet us at the next country. So anyway, my friends, we're going to build a new application. We've got a public static void main entry point into the application. Let's make the font just a little larger. It's already larger than life, but let's make it a little larger. And we're going to build an application that writes data to the database. We're going to create an entity that's going to be mapped to a SQL database table. I have PostgreSQL here, right? It's running in the background. Ooh, that's a problem. I'm glad we figured that out. Postgres. Okay, pSQL, U orders.
There we go.
Okay. Select all from reservation. You can see I've got that, right? I'm going to delete this from reservation. And now, if I look at that, I've got this table with a primary key, an integer, and a name field called, which is a string. So we're going to describe that here. Private integer ID, private string name. Now that's the essence of the entity, but of course, I want to map this to my database, so I'm going to use @ID to signal that this is the primary key. And of course, it's Java, so I need getters and setters and all that kind of stuff. So I can do this, I can do that, I can do this. You know, I can just throw away my code if I want to. Get rid of all that. Good stuff, right? More constructors, good. More constructors, so good. So there we go. There's everything I need to be productive in Java 2019. Obviously, I can do better. There's a couple of options here. One is I can use any other language at all, ever, just anything. You know, anything on the JVM will work just fine, except for Java. Or I can use Lombok. Lombok's a compile time annotation processor. I just add these annotations, and it gives me the same thing. And now I want to persist this into the database. So I'm going to create a repository. This is a reactive CRUD repository. It's going to manage data for us. It's going to handle the data lifecycle.
So this is, of course, using Spring Data's repository abstraction, right? Mm-hmm. So in Spring Data Moore, we also have a corresponding Spring Data RTDBC module coming with it. So the model should be familiar to anyone having used Spring Data before. Keep in mind there's a dedicated hierarchy for the reactive repository variants. They are pre-typed for the reactor return types.
Right.
That's what we're going to just silently use here.
And so you can see there's two, yeah, like you said, they're pre-typed for the reactive return types. So we have the first one, which is a publisher. A publisher comes from the Reactive Streams specification. This is not our effort. This is a joint effort by Pivotal, by Netflix, by Lightbend, by the Eclipse Foundation to describe asynchronous, unbounded, latent streams of data. It describes a thing that publishes data asynchronously. There's a subscriber, which consumes the data. So in the onNext method, as new data arrives, we get the onNext callback. If there are any errors, the onError callback is called. And if we are done processing, the onComplete callback gets called. I skipped over onSubscribe because this is arguably the most important part. Here, we have a subscription. And the subscription is the thing that allows the subscriber to ask the publisher for more data or for less data. You can request 10 more records. And if you ask for 10 records, you might get 10 records in 10 years or 10 nanoseconds. It doesn't really matter, right? You get them and no more. You won't get 11. You'll get 10. If you want another 10, you ask for 10. If you want to just stop the rate of production, you call cancel, right? This is called flow control.
Yeah, so it's, of course, whoever owns the subscription is in the driver's seat. This very fundamental abstraction, it's actually no more than this, right? This is basically it. This is Reactive Streams. This is a very low-level way of modeling the interaction, almost like a protocol of interaction between different pieces in the runtime stack. This would, in our case, of course, include the web runtime, like the HTTP response and its buffering, interacting with a data store driver that is able to produce a result for us. As the data becomes available from the data store, we have a subscription with the HTTP response, and as we can fill the buffer in the response, we're going to request further data from the data store, all in a fully non-blocking architecture. So there is no blocking involved. We only process data as it becomes available, as we're able to buffer the outcome and forward the outcome to the web client.
So these are the three most important interfaces, I think. But then there's also processor, right, which is a bridge. It's just a publisher and a subscriber.
Yeah.
Right? And then we also have these four interfaces. That's the Reactive Stream specification. If you understand that, congratulations. You're already certified reactive, right? You can go to Silicon Valley, raise millions of dollars, have crazy parties. You're ready, right? You've already got more than most people in the Valley do. But these are very boring. They're very simple. They don't provide operators. So we have Project Reactor. Reactor provides two specialized types. The first is a flux. A flux produces 0 to n values, where n is potentially unlimited, okay? But it has all these operators like map and flat map and combine and all that kind of stuff, right? We also have a mono. Mono is a publisher that produces 1 or 0 values. That's it, okay? It's like a completable future kind of, but with back pressure.
Yeah. So mono and flux are the two essential entry points into the reactor programming model. They are high-level composition types with many operators, but both of them are at the heart of what they're doing, and quite literally, they are implementations of Reactive Streams publishers. They also compare quite nicely to the well-known RxJava types, like in RxJava 2, of course, with like flowable and single. In RxJava 1, this was the observable type. So it's kind of playing in that game, a rich composition library for reactive pipelines. Whereas Reactive Streams itself really just models the underlying interaction between the pieces and is of no immediate interest, really. You would typically start with a high-level composition library, your choice of Reactor, RxJava these days.
Yes, yeah. So now we have, I'm going to create a simple pipeline to demonstrate all that working. I'm creating a simple pipeline here. And what I'm going to do is I'm going to, second one, I'm going to create a pipeline of names. And I want to take each name and write it to the database using these reactive types, okay? So let's just go through each name like that. And I'm going to visit each one. I'll say names.map, new reservation, passing in null there, okay? That's a reactive stream of reservations. There we are, reservations. And I want to save each one to the database. So I'm going to visit each one of those. I could use .map, and I could just say it like this. But the problem with that is that this method, save, it returns a mono of reservation. Well, of course, if I do that, then what I have is a reservation. I have a publisher of reservation. So instead of doing that, I use a flat map, right? That gets rid of the intermediate type here. Good stuff. So now we have just the save data. Now, of course, if I run this code right now, nothing happens, right? And the reason nothing happens is because this is a cold stream. We've connected the pipes together, but there's no water flowing through the pipes. We need to subscribe to turn on the pipes, to turn on the water, okay? So if I subscribe like this, it'll start running. So this is fine, but if I run this program multiple times, I'll get data in the database. I'll get the same data multiple times. So what I want to do is, first of all, clean this code up a little bit. It's 2019. You can simplify your life, right? First of all, get rid of all that. And then I want to delete everything in the database first. And then I want to find the data. I want to write the data to the database. And then I'm going to find all the data, like so. And then finally, I'm going to subscribe to the results, okay? Now, in order to subscribe, I could provide a consumer or a subscriber or anything else, right? And I can do that here. I can just say system out print line, like so. And of course, this becomes a nice lambda, so good. And that becomes a nice
method reference.
Method reference, thank you, Juergen and IntelliJ. There we go. By the way, that act right there, what just happened, where he corrected my code, that's called being Juergenized. And it's an honor.
Happens all the time.
Yeah.
To everyone, including myself.
So now we've got data. Let's run this program and let's see if it works. Do you think it's going to work?
Let's pray.
Okay, it did not work. It's saying I need a database URL. So let's go to here and say R2DBC URL. Don't tell anybody about my database connection string, okay? So there we go. Localhost orders, okay? And then there's the username, orders, and there's the password, orders, okay? Shh, don't tell anyone. It's our secret. So there's our build. Did it work? Look at that.
Did it look good?
It worked. Of course it worked, my friends. That was a demo. What were you expecting? That was always going to work. There was no question about that. What I really wanted to show you, indeed, the reason that Juergen and I traveled around the world to be here is because we wanted to talk about the ASCII artwork. This artwork took a long time to get right, but we on the Spring team have many people who are doctors, PhDs, who worked in their previous lives in nuclear physics. And so it's for this reason that I want to take a brief moment to talk about what I consider to be a glaring and serious deficiency, a bug in the IntelliJ JetBrains product. Because even though I'm a fan, I consider this to be short-sighted. Do you see this checkbox right here? This one right here, this one. Do you see this checkbox, this one right here? Do you see it? That checkbox? Do you see that checkbox right there? This one. There. Do you see it? That one? That one right there. That checkbox, once clicked, hides the ASCII artwork. What the heck? Why is that there? That's a dumb feature. Nobody even asked for that, okay? I don't even know why that's there. So I did what all people would do. I went on the internet and I cried. And I was given a message of hope from my friend Jan Sebron. This is Jan Sebron. Jan Sebron is a developer advocate at JetBrains, right? This is him right here. That's him. he sent me this message of hope, which I want to share with you here today. Every time I talk to him, he says, don't worry, Josh, relax. It'll be fixed in the next release, Josh. It'll be fine, Josh. Just relax. Every time he says that, and I want to believe him. We've been friends for years. I want to believe him, but you know what? I'm starting to think that maybe, just maybe, maybe he's not telling the truth. Whatever. Now I have data in the database. It's up and running. Now what?
Yeah, let's
We've got
see what happens if we break it. The model that we've seen up until this point is basically a pretty manual use of the Reactor as a library. Of course, what we do within Spring, the Spring programming model, is we integrate it into our vision of reactive programming within the architectural pieces that we're providing. So you typically wouldn't subscribe yourself. It would be pre-integrated. You return a reactive pipeline, a Flux or a Mono, and we know what to do with it. We automatically subscribe it to the web response or to the messaging channel. And we also allow for some sophisticated, decoration, right? Like reactive transactions are effectively a form of decoration of a Reactive Streams publisher. So, from where we are right now, we have the data in the database, right?
Yep, we've got the data in the database. I want to write the data to the database, but what if I wanted to introduce some validation or something like that?
Yeah.
Okay.
Let's check the casing, maybe?
Maybe create a service? Yeah, okay. So I can create a service to help me validate the writing of the data. So I'm going to just create a service like this, save all string.names, okay? And what I'm going to do is I'm going to, inject that repository, the same repository that we saw earlier. Here we are, okay? And this is just going to be a regular service, and I'm going to inject it into the constructor, so I can use Lombok. Lombok's, again, it's going to help me out here. I'll just say required args constructor, and voila, there's the data. And I want to write all the data that I see in that array into the database. So there's my stream of strings, and for each stream value, I'm going to turn it into a new reservation, passing in that, like that. And it's just the same thing as before. And so for each one of these, I'm going to say flat map R, and I'm going to write it to the database, okay? So there we are. And there is the reactive stream of data, but I want to actually now persist this to the database. So of course, I could just return this, right? It's actually, somebody else is going to subscribe to this. I could return it. But before I do that, I want to make sure that certain things are well taken care of. I want to make sure that each name has the first letter starts with a capital letter, right? So for each reservation, I want to then validate that the name starts with a valid letter. So is capital, is name valid, okay? So for each reservation, I'm going to say, give me the name, and I'm going to say if name dot character at, well, first of all, if name does not equal null and name dot car at 0 dot is a capital letter, right? So character is uppercase. Then I want to return true. Otherwise, just return false, right? So that's a very simple little algorithm there. Clean that up a little bit. So now I want to visit each one. For each element in that pipeline, I'm going to say assert that this is true. Is a name valid R? The first letter must be uppercase, okay? So now if I run this, what's going to happen? I'm doing the validation after I do the write. That could prove problematic. And I certainly don't want to write. What if I write 3 names?
What if previous elements have already been written?
Right. We've got a problem here.
Yeah.
So how do we solve this in the reactive world?
And that's exactly where reactive transactions come in one flavor. We're in here we're in the programmatic world. We're trying to stick with that paradigm for the moment. We have 2 variants of reactive transactions in Spring Framework 5.2. One of them is a transactional operator. This is basically literally a programmatic decorator for a target reactor pipeline that you can just apply, as we're going to see. The operator does need a transaction manager, though. It needs to know which transaction manager it's going to delegate to. Just like with regular Spring transactions, where it's a platform transaction manager, in the reactive world, we need a reactive transaction manager implementation. So there's a dedicated variant of that SPI, and reactive transaction manager implementations come primarily in Spring Data more, for like MongoDB, for Neo4j, for R2DBC, in Spring Data R2DBC. So the transaction model is the underlying data stores model. We're not doing anything fancy, right? We're literally just interacting with the underlying data store, creating a corresponding transaction context. That transaction context is stored in what we call the reactor context. It flows along with the pipeline as we as reactor goes through it. There's contextual attributes flowing with it. This transaction context being one of them. And data store operations within that pipeline can pick up this transaction context from the reactor pipeline and interact with it. It's similar to, in a traditional world, the thread local bound JDBC connections that data store operations would pick up and perform the operations on, and they implicitly participate in transactions that way. Here it's not thread locals. It's a decorated reactor pipeline with a contextual attribute in it. And of course, there's the transaction operator, the programmatic variant. But there's also an integration with @transactional. So @transactional basically differentiates based on the return type signature, whether this is a reactive method building a reactive pipeline or a regular method. And it has two paths of operation, the platform transaction manager one and the reactive transaction manager one. Both activated through @enable transaction management, and basically just adhering to what you declared in the programming paradigm that you're using.
So I'm going to use the transactional operator version. I'm going to rewrite this code that we've got here that writes data. I'm going to rewrite it so that it takes advantage of that explicit declarative sort of transaction demarcation. I'm going to say return this transactional operator .transactional string flux. Okay, and that's
all you have to do, right? This final line is performing the decoration. If you would be using the annotation-based model with @transactional, you would just return the original flux as you got it from the repository, as you took it from there, and this decoration would happen through @transactional's processing of the return value.
So select all from reservation. There's nothing in there, right? So it got it. If it it executed, it would have written Juergen, but it should not have written anything.
But there's a lowercase Josh in there.
Right. So it deleted. It rolled back everything. Right. That logging is just logging.
Make it an uppercase Josh.
Yeah. There we go.
You really should be uppercase after all.
All right. So we've got data in the database. We've got reactive transaction management. We know that we can do it with MongoDB, with Neo4j, with R2DBC. Now I think we should go to the web. We need an HTTP service.
Let's take it to the web.
Okay. So what's the first approach that you recommend using? Right. We can use a REST controller, I guess.
Yeah, there's of course, the good old, actually not that old, annotation-based programming model for reactive endpoints introduced in Spring Framework 5.0. The reactive version, right? The original dates back to 2.5, of course, but the reactive version of it is a Spring Framework 5 feature that we are taking forward. It's one of the two programming models that we're providing. There's the annotation-based variant with the Spring MVC style endpoint model. And there's, of course, a functional model in parallel to it, sometimes dubbed webflux.fn. The annotation-based model is very straightforward. It's basically using the same pieces, the same annotations, and the same declarative model that you're used to from Spring MVC's perspective. A reactive endpoint along those lines can even run in Spring MVC and be adapted there, but on the Webflux stack, on a Netty-based event loop stack in particular, you really have to enforce that all your endpoints, your annotation-based endpoints, use the reactive programming model. Webflux FN, on the other hand, the functional model is a bit of a purer programmatic form of composing your endpoints. So the idea in Webflux FN is that we break it down into router functions and handler functions. We're basically building a sequence of routes, connected routes, where an incoming request maps onto a particular handler function, and then you just associate the actual handler function that takes an incoming server request and builds an outgoing server response. Pretty programmatic. It's lower level in some form. Some of the convenience of the annotation-based model isn't immediately available here, of course, but all the functionality is. And stylistically, we follow guidelines that have been established back with Java 8. The kind of functional API design, as in Java util collection, streams, the Java util function interfaces. That style of API is what we are using here as well.
So there, I've done it twice now. We did it with the REST controller, same thing, and then we did it with the functional reactive style. Yeah. And so to build our API.
Yeah, right? The build API is also, of course, very self-explanatory. It has all the options available, and it's very, very efficient. There's no reflection involved. It's also the purest form in terms of runtime performance.
Right. Okay. Well, so now we've got an HTTP service. There are all the analogs that you'd expect, by the way. So you can do. Did you mention the webflux.mvc? Or the functional reactive MVC?
A side note: in Spring Framework 5.2, we have the same functional model also for MVC for servlet requests and servlet responses. So we are really taking this to places. So the annotation-based versus functional arrangement is now available for both Spring MVC and webflux. Right. But for our purposes, we'll keep running on webflux.
Right. Good stuff. So we've got this. And by the way, when we say webflux, like you said, this is not a servlet API. There's no servlet engine here, right? We're built on the ground up on top of an IDI to support asynchronous I/O. So this is a brand new, net new reactive web runtime to support reactive processing. So now we've got data in the database. We've got a simple API with we got 10 JSON records. We're talking to a SQL data store. So what? Like, I know you can all do this already, right? You could have already done 10 records from a JDBC database yesterday. You don't need reactive programming for that. Where's the big value here? So I think it's worth considering a use case that requires, a use case that would have required, in traditional terms, a continuous thread, something that requires liveliness, right? One of the best use cases for reactive programming is when you're dealing with something that might monopolize or, continue using a thread. And what kind of things traditionally do this? Well,
there's quite a few use cases in the web world. You could do server-sent events, which already goes into territory along those lines. You could do web services,
stock tickers, chats,
any kind of longer running stream-like responses where data only comes in periodically or even unpredictably, and you don't want to block and wait. You basically want to be called back and produce the data as it becomes available. So in particular for those use cases, we're really where reactive programming shines. But then there's also a reactive messaging arrangement now in Spring Framework 5.2, where we're venturing beyond pure web territory. Spring messaging, of course, has been around for a while. This is an endpoint model that we're using for example, for Stomp on WebSockets. We're also using it for JMS and AMQP in specific forms. And now, as of Spring Framework 5.2, there's a reactive variant of it, a reactive messaging model with reactive messaging integration.
Is that correct? Okay.
And this is exactly what we're going to build right now here. An
infinite service. Well, then we'll talk about how to get it up and running and exposed to the world separately.
So incoming greeting requests we have, right?
Right.
Greeting request messages, greeting responses being produced.
Right.
And well, I haven't mentioned so far that our reactive programming model in Spring Messaging basically has one primary binding that it comes with in our current generation of the framework, and that is RSocket.
Right. We'll talk about that.
So RSocket, of course, is a brand new industry initiative, a collaboration with many stakeholders, like Facebook, Netflix. Yeah. There's strong industry interest in this. Netify as a provider, of course, for an RSocket broker product. The RSocket model, in its essence, is actually very simple. it's a modeling, it's kind of a modern rethinking of messaging architectures. And it's modeling 4 basic interaction models, like a request-reply, a request-stream, a fire-and-forget, and a stream-stream model, a channel-based model. Interaction models between peers in a messaging architecture, distributed peers.
So we have a little bit of time. Can I quickly show them a service and event version of this? Because the question is, how do we get this infinite stream up and running, right? How do we consume that? And you mentioned service and events. That's a great, easy thing to show, right? And you could mention WebSockets, right? That takes a little bit longer. I don't have time for that.
Yeah, we'll focus on RSocket primarily.
But we've got this infinite stream, right? I'm creating a new piece of data using a supplier every second. I'm using the scheduler here, right? This scheduler is what allows the runtime to introduce 1 second of time between each new message. That scheduler is underneath everything that we're doing with...
This is Reactive scheduler, right? It's at the heart of Reactive's runtime processing. There's a scheduler. It's usually bound to an event loop. You can choose to subscribe on a different scheduler. In case you have operations that have special runtime characteristics, or if you're trying to adapt blocking operations into a reactive pipeline, this is necessary. In many other scenarios, you're perfectly fine if you just let Reactor schedule it on its default scheduler.
And by default, it's 1 thread per core, right? So it's very important that you do not block.
Classic event loop architecture.
Yeah, it's an event loop architecture. Super important that you don't block, though. Remember, if you've got 4 cores, that's, and you block 1 thread, you're blocking 25% of your users, right? You've got to make sure you don't block anything on the scheduler that is provided by default. You can move, as Juergen just said, you can move work from 1 thread pool to another, 1 scheduler to another, but it's very important that you are aware at all times of what scheduler you're using. So there are easy ways to move work from 1 thread pool, from 1 scheduler to another. You can create your own scheduler as well. But if you're worried about accidentally doing that, if you're worried about accidentally doing something that blocks the thread, there's an easy way to detect this. And by the way, it's good to consider what kind of workloads block threads. What kind of things will actually block threads? There are several things that are CPU bound, right? These are things that are going to just sit on the thread. If they're not I/O bound, then potentially you can move them to reactive programming by taking advantage of asynchronous I/O. But if they're CPU bound, if you're doing things like cryptography, right? If you're doing things like the Fibonacci series, if you're doing things like Bitcoin mining or running Slack, these take up CPU. Lots and lots of CPU, right? So what we want to do is make sure that we move those things off the CPU, or at least we identify them. So we have a very nice product, a nice tool called BlockHound, right? BlockHound, actually I have it in a bookmark here, is a great project by our Reactor team member, Sergey. It's called BlockHound. You can just add this to your class path, right? Blockhound.install. You just say blockhound.install, and whenever you do something like sleeping or running Fibonacci or Bitcoin mining or cryptography, anything that would block a thread, it'll throw an exception telling you that you're blocking the thread. Now you can write code that is reactive safe. It can work correctly on the schedulers that you've got.
You probably would notice a thread sleep operation if you're reviewing your code, but it might not be so obvious in other cases. So BlockHound is really a great tool to a kind of validation of your interaction model, where you're not where you're preventing yourself from accidentally using blocking I/O operations. And there's lots of potentially blocking operations. Think about everything from input stream, output stream to JDBC to JPA. Those kinds of operations can be a part of a reactive pipeline, but they need to be a properly integrated part with a bound scheduler that they are running on, keeping the original event loop available for incoming operations. So we got many pieces of the puzzle in place here that allow you to do even larger scale, of course, reactive programming with tools in place that just make sure that no accidents sneak into your code.
So I've taken our little greeting service, which is infinite, right? And we're going to go to greetings, Joker, okay? And that's just a service and event stream.
Yeah, this is a plain web endpoint that just every second, right?
Yep.
Just drops a piece of data onto the wire, and in a very efficient form. It's literally on the reactive scheduler every second there's a callback that produces the data and just forwards it to the HTTP response.
Right.
So this is, of course, a simple use case, right? Server-side events.
Yep.
Now let's switch to RSocket territory.
Sure. Now,
RSocket is a pretty sophisticated architecture.
Much more sophisticated. Right? Keep in mind, every second that it produces the new message, it's going to send the message and then free up the thread. So somebody else can reuse that thread. That's the benefit here, right? In between those raindrops, for every second, somebody else can do work on that thread. We don't have to keep using it. That's the real power here. Reactive programming is not about making one transaction faster. It's about making it so that you can handle a lot more transactions. That's the big win here, right? That's the thing that we're trying to get, is to handle more transactions, more requests with the same computer. So that's the big win. Now, we did server-side events. That's an okay approach to exposing data on the internet. We could have done WebSockets, but there's some issues here, aren't there? WebSockets, server-side events is HTTP. If you're using HTTP 1.0, that means that you have to reconnect and disconnect each time, or 1.x, right? If you're using HTTP 1.x, you're using text, right? It's text-based, so you have to take everything that you're doing, including binary data, and convert it into text. That's awkward. If you're using HTTP 2, this is a little bit better, right? You have binary encoding, right? But that's one thing. And you also have pipelining. But that's not the same as multiplexing, right? I can't handle multiple things safely and efficiently that way. So we have some limitations with HTTP. Well, what about WebSockets, right? WebSockets, that's a nice fit, right? WebSockets are a binary protocol. It also gives us a different exchange pattern. Instead of making a request and getting a response, we can actually have a conversation, right? WebSocket client and service. This is very nice. I like WebSockets, but there's some limitations there too. How do you do security? I mean, there's headers in the HTTP upgrade connection, right? But there's no headers in the WebSocket payload itself. So in the Spring team, we have talked about using Stomp for years. We've talked about Stomp as an envelope in your WebSocket message, and the envelope has headers.
And that is pretty popular, right?
Yeah, but it's a hack. It's a disgusting hack. The WebSockets itself have no headers. It's a bit of a shame that the protocol has this limitation, because it could be very useful, right?
Yeah, WebSocket itself is just too basic, right? For many purposes.
Yeah. So RSocket, where'd that come from?
So the back to the RSocket story. This is reactive from the grounds up. It's this reactive rethinking that I've hinted at. Reactive revisiting of messaging architectures goes to the extent that there's a notion of back pressure over the wire. Flow control is a key piece of the interaction model. It's also designed for a longer running interaction sessions, with session resumption being a key feature of the messaging architecture. So we think about like mobile clients on less than stable connections, many mobile client connections to a server-side service. That's exactly what RSocket has been designed for. And it's a very close alignment with the Reactive Streams specification. So it's literally almost a Reactive Streams taken to distributed architectures and taken to the wire protocol level. But talking about wire protocols, RSocket is an abstraction. So RSocket comes with a transport abstraction and several bindings, right? You can run RSocket almost on any kind of lower level transport architecture. The model, what I personally particularly like about RSocket is that the model is very simple and straightforward, easy to grasp, a very immediate translation of our interaction patterns onto a concrete messaging architecture. Right, so what did we do with it? Well, we made it a part of our story. The programming model in Spring messaging is very similar to the Spring Web programming model anyway. And an RSocket binding literally looks like what we're seeing here. It's an endpoint with a message mapping annotation, follows basically the same design as a reactive web endpoint. It's also very similar to a Stomp endpoint on WebSockets. The incoming payload is, of course, kind of converted and passed to the method. And the method just instructs us how to deal with an interaction coming in on that channel. Keep in mind, a reactive endpoint always builds a pipeline and leaves it up to the runtime system of when and how to apply it. Right? So it's not actually performing the interaction, it's building instructions for the interaction.
So we've got the RSocket service over here. We've gone to the property file. I've set up the port. I said I want to run an RSocket service port. It's up and running. Now on the client, I'm building a client object, an RSocket requester. The RSocket requester is going to connect to the RSocket service on port 7777, right? That's what I specified back here. Now, keep in mind, we're creating the RSocket requester when the application starts up. RSocket gives you stateful multiplex connections, so you can connect and stay connected. One of the reasons that HTTP is so inefficient is because you have to constantly connect and disconnect. This time, you stay connected, so you're always live or always ready to go. You can do reconnect logic if you want, but the point is this is a pretty sane pattern. It creates an RSocket requester, and then you can use that. Now, the reason we say RSocket requester instead of RSocket client is because once you're connected, you're peer-to-peer. It's both sides can send messages back and forth at any time they want. It's a conversation. It's not a request-response. RSocket, as he just talked about, supports other message exchange patterns. So we can send in a stream of data and get a stream of data back. We can send in a single value and get a stream of data back. We could send in something and then get nothing back, like fire and forget. All these different sort of kinds of interaction styles that you can't really support easily with HTTP. So what I'm going to do now is I'm going to use my RSocket requester to make a call to the greetings endpoint, which we've mapped here. And the problem is that as I'm writing this code, I'm not getting very far because I don't have these types on the class path. So I need to do something terrible, something that you should never, ever do, ever. Not even when you're all by yourself at home and no one is looking. I am going to copy and paste code. So here's this. There's my greetings request and my greetings response. These are the two things we're going to send across the wire. I'm just going to use them as a DTO. We're going to say new greetings request, and we're going to pass in a name. Okay, so let's see, what's a good name that we could use? Var name. Oh, I did the wrong thing, friends. I did the wrong thing. I did bad. Haste makes waste, friends. Don't do that. Think of the kids. Now, we've got the RSocket requester. We're going to retrieve the greetings responses that come back. The name that we're going to send across the wire is going to be Joker. Okay, there we go. And we're going to subscribe to the data. And as the data comes back, we're just going to log it out, right? Just a very simple thing here. Now, I'm going to use a logger from log4j, or from log4j using a lumbuck. And there we go.
What we're seeing here is also a good example of this pretty comprehensive toolbox that we're providing. This is a programmatic piece for initiating RSocket interactions, right? So a counterpiece to the endpoint model that we've been seeing. So this kind of annotation-based versus programmatic variant approach that we keep elaborating on is also showing here.
Okay.
Right. So we got the service running in the background.
Yeah.
Yeah.
You can see that it's sending these requests over the wire using this native network protocol, this binary network protocol that doesn't care what payload you send in it. Now, RSocket is not just a much better WebSocket, right? It's actually built from the ground up for production. It was oriented for production. So things like security, you can do that because you have headers in the payload, in the message itself. Another thing that's very nice, how many of you have ever used the Spring Boot actuator? Spring Boot actuator. So you know, actuators are awesome. There's HTTP endpoints. They're endpoints, JMX or HTTP or whatever, that you can expose in your application for clients to consume. They give you information about the state of the service. They tell you about the state of the application that you're making a request to. The question that, the question of, hey, are you healthy? Is your service running okay? Do you have enough capacity to handle my request? You can ask the actuator endpoints that information. The actuator endpoints articulate the state of the individual service. Who better to articulate that state than the service itself, right? Your operating system and all these other things doesn't have a very good, clear picture of what the state of the application is, because the CPU might be 100% and that might be okay, but that doesn't mean you're healthy. It doesn't mean your service is healthy or not, right? Only your service truly understands its own state. So RSocket has a message frame as part of it, a part of the protocol that supports articulating, conveying the information about the state, metadata, right? This makes it very easy to do very interesting things. So we've created this thing right here, but Imagine now having a smart client that connects to a service and says, hey, service, are you healthy? And if it is, it can make the request. If it's not, it can load balance to another node, right? You have some very interesting possibilities with RSocket here. You have full bidirectional communication. It's multiplexed. You've got stateful connections. You've got smart load balancing possibilities. And this gets us to a very interesting possibility that was enabled by the recent creation of RSocket support in one of our projects called Spring Cloud Gateway. Now, Spring Cloud Gateway is a proxy. It's a gateway for services. It can actually connect all your different RSocket services to the gateway as a hub, and then they can do smart load balancing there.
Yes,
now,
in that sense, RSocket is also an enabler for a whole ecosystem of infrastructure providers.
Yeah.
That's also a great value in its own right.
Now, of course, because this is a natively reactive protocol, because on the wire it's reactive, you can do things like sessions resumption and cancellation, and you can pause, You also get all the benefit of the operators. So let's say that something goes wrong and you want to retry. It's very easy to say retry. You can do back off. You can say I want to retry 10 times, that kind of thing, right? You have lots of possibilities here that just work, right? That do what you want. You can also do timeouts, but maybe don't do that. I'm not sure that timeouts are the best approach for services. You should use something like service hedging. And this is possible with these reactive APIs. These reactive APIs make it easy for us to describe reactive, asynchronous, unbounded, latent streams of data. It makes it easy for us to combine and compose them. One pattern that people often ask about is, hey, I have a service over here and I have a service over here. It could be RSocket, right? And I want to connect these different services. I want to connect these things together. Well, it's easy to launch a request into the network at the same time using Reactor and asynchronously process the streams of data as they come back. Another question is, what if one of my services is slow? Well, I could use a timeout, but what happens if you have a timeout? You make a call to another service. Let's say that your service has a timeout, an SLA of 10 seconds. Whoops, that's not it. That's the wrong one. Let's say that your service has an SLA of 10 seconds, right? If your service has an SLA of 10 seconds, the services that you're connecting to, well, how long is their SLA? Maybe it's 5 seconds, right? Because, of course, if they fail, you want to retry and do it again within 10 seconds. Okay, what about that service? This service that takes 5 seconds, it's connecting to another service. What's its timeout? Well, now it's 2.5 seconds, right? So it gets smaller and smaller and smaller the further you go because you want to have one time to be able to reconnect. This gets to be very problematic at scale. So one pattern that is very, very convenient, that's very easy to do in a reactive world, is called hedging, right? Hedging. Hedging is where you make a call to another service. You make the same call, the same network request to, say, 1 service, 2 service, 3 service, like this. So let's say I make a call to some other service and I get back a greetings response, right? Right, 1. Let's just, I'll assume I have just copied and pasted the code from below. I've got 3 different services here. Okay, I've got all 3 of them. And I want the first one that produces a response to win. That's the fastest. That should be the best one. I can do this very easily using reactive APIs. I can say greetings response 1, 2, and 3, right? This makes it so that I can now get the fastest one and apply back pressure to kill the other 2, right? Very easy pattern to support. Reactive APIs make this possible. RSocket makes it even more possible.
And in that sense, this can be an essential enabler for, message-oriented microservice architectures. We envision that the RSocket is kind of a central piece of your architecture, not just something you do on the side. This is also, again, sort of our toolbox approach. If all you need is a little bit of interaction over a web channel, longer running interaction, we have server-side event support, we have stuff like deferred results, reactive endpoint support on serverless architectures. We have the WebSocket support, if that's what integrates best with your infrastructure. But if you are composing or re-architecting a system, a highly distributed system with many special service level agreements in place, then an RSocket-based architecture may be the most natural translation and the most powerful and sophisticated version of what you mean to architect. So in that sense, there's a whole class of applications emerging here, RSocket-based Spring applications.
Absolutely. Good stuff. Who had fun? Good stuff. Who learned something new? Oh, good stuff. Pasibo, my friends, thank you so much. Before we go...
Yeah.
Oh.
Thanks.
Good job, buddy. Before we go, later on today at 2 o'clock, I'm doing a talk on testing. Juergen is doing a talk introducing in much more depth all the new stuff in Spring Framework itself.
5:30 in the afternoon.
Sergey Egorov, one of our teammates, is doing a talk on containers, test containers. And Ole, our buddy Ole, is doing a talk on fine-tuning reactive apps. So you should watch the videos or go see those talks live or whatever.
Yeah. Plenty of good reactive content here still.
Thank you, guys.
Thanks. Enjoy.